Alright, this video I'm going to talk about osmosis. Alright, when talking about osmosis, osmosis is a simple diffusion, a passive transport, but is literally the movement of water, which is the universal solvent, to an area of high concentration of solutes. Now, solutes most often in the body are going to be things like salt and sugar like glucose. So water always moves to the highest area of solutes. Now, when we talk about water, we have to talk about the inside of the cell versus the outside of the cell. So when we talk about one cell, the inside is called the intracellular fluid. The intracellular fluid is going to be cytosol, which is going to be a concentration of solutes and water. And then you have your extracellular fluid. Extracellular fluid is the fluid on the outside of the cells, which also has a certain concentration of water and solutes. So we have what we call solutions. So we can literally, in the extracellular fluid, so NaCl, that's salt, which we're going to draw as little dots. So dissolved in our extracellular fluid, we're going to have sodium chloride. Now we compare the amount of sodium chloride on the inside. Sometimes sodium moves on the inside, but you have more abundant on the outside most often. So when we talk about this, we would say that there's an osmolarity or osmotic concentration gradient. So this is a high concentration of solutes on the outside versus a low concentration of solutes on the inside. So when we talk about water, water always moves to the area of higher concentration of solutes. Water is H2O, so we have fluid on the inside. So water in this situation would be moving out. Water is the universal solvent, so water is always going to move to the area of high concentration, to an area of high concentration of solutes. So water wants to go to the area where you have more solutes. Now you could reverse the situation where you have more solutes on the intracellular fluid and water would come in. But before you even talk about basically the water movement, you need to understand a couple of definitions. So when you say osmolarity, this is the concentration of solutes expressed as a total number of solutes in a concentration. So osmolarity. This is the concentration of solutes in a solution. Per liter. Now, another definition that I would need to talk about is what we call a concentration gradient. A concentration gradient is a difference in amount of substance between two areas of the cell, the inside versus the outside. So this right here represents a concentration gradient. So there's a different amount of solutes on the inside versus the outside. There's a concentration gradient. So the technical definition is there's a different amount of concentration on one side of the cell compared to the other. Now, osmolarity, when we talk about an osmotic gradient, basically we're just comparing the solutes on either side. So instead of saying concentration gradient, you would say an osmotic gradient. An osmotic gradient is referencing the number of solutes in a solution on two areas of the cell. So when we talk about osmosis, water always moves to the area of high concentration of solutes. Now, another term that we use is tonicity. Tonicity is pertaining to basically osmolarity. When you say something's tonic, you're talking about the number of solutes inside of a solution. So I always like to review what a solution is. So a solution is a mixture of a solvent, which is the universal solvent is water, plus solutes. So technically, when we look at the intracellular fluid and extracellular fluid, it is a solution with a certain amount of solutes. So when we talk about solutions, there's three different types of solutions that we say. When you say you have an isotonic solution, the word iso means the same. So you have the same amount of solvent as you do solutes. So iso means equal. So you have equal amounts of solvent and solutes in a solution. When you say you have a hypertonic solution, I always think of hyper as like a kid. So if you have a kid that's hyper, what do you have more of? Well, it's obviously more sugars. So solutes are always going to be substances that dissolve inside of a solvent, which is going to make your solution. So a hypertonic solution is going to be a solution that contains more solutes than solvent. So remember, water is your universal solvent. Water dissolves most things, and your solutes most often in the body is going to be table salt, which is sodium chloride, but it's also going to be things like glucose, sugar. Sugar is going to dissolve in water. So you can have a sugar solution, you can have a salt solution. So if you have a hypertonic solution, I think hyper for kids, you're going to have more sugar than you would solvent. So the last type of solution is called a hypotonic solution. A hypotonic solution is a solution with less solutes. Hypo means below, hyper means above, than solvent. So when we talk about cells and what happens, we need to understand these three different types of solutions in terms of osmolarity, because you can have osmotic gradients, a different concentration of solutes on the inside versus the outside. So if we were talking about the extracellular fluid, we can just look at the percentage of solutes on the inside versus the outside. And basically, you have to remember water follows the party. That's kind of like what I always say. So I want to talk about what happens to our blood cells in different types of solutions. So we can demonstrate this by filling 3 beakers with different types of solutions. Now, we are going to say that these solutions are the extracellular fluid. So we are making 3 beakers with 3 different types of solutions. So what you have to do is you have to add water to all 3 of the beakers, like this. That's your solvent. And we want to dissolve different amounts of solute inside each one. So this one we're going to say is an isotonic solution. So we can say that we have a certain amount of solutes compared to solvent. So this is my solute. NaCl is my solute. Let's just say it's 30% sodium chloride, and we can go ahead and say it's 30% water. That would be a isotonic solution. So we would say it's isotonic because it has the same concentration of water as it does salt. Now in the next one, we can put a lot of salt in here. We can just fill this beaker up. So since we said this was 30% water, we can keep it at 30% water. However, when we look at the solutes, let's just say this is a 75% solute concentration of sodium chloride. So we would say that osmolarity wise, it's 75% of solutes. Now, the type of solution is going to be hypertonic because there's more solutes than there is water. Now, this last one, let's say that there is a 3% sodium chloride. That's very low compared to your 30% H2O. So we have 3 beakers here with 3 different types of solutions. Remember that the whole premise of this is that you understand a solution is a constant, or basically a mixture of a solvent, which is water, plus solutes, and we're using salt. Now, if we compare cells, if we take a cell, the intracellular fluid is, let's just say 90% water or 30% water. This is just fake numbers. And 30% sodium chloride. Table salt. So we would say the intracellular fluid is isotonic. So this is a cell, and the fluid that we're going to place this cell in is going to be the extracellular fluid. So to determine the direction of movement for osmosis is water. The movement of water or a solvent always moves to an area of higher concentration of solutes. So basically, we're going to call this a red blood cell. So we place a red blood cell in each solution. Now, we know that the solutions that we placed in each beaker are different. This one is an isotonic solution because it was 30% water and 30% sodium chloride. This one was 75 and 30, so this one was a hypertonic solution. And this one is 3 and 30, so this one is hypotonic solution. Now, the fluid on the outside represents your extracellular fluid. Your extracellular fluid is going to have a different percentage of water and solutes. That's what these are going to represent. So when we talk about the surrounding fluid around a red blood cell, that would technically be called your plasma. That's your extracellular fluid. But in each one, we already know that a red blood cell has 30% water and 30% sodium chloride. So on the inside of this one, we would say it is equal on the inside to the outside. So when we say water, osmosis moves to the area concentration of solutes, well, technically, we have 30% sodium chloride in here as well. So osmosis will occur in this, but in equal directions. So in this one, water will move out of the cell, but water will also move into the cell. So in an isotonic solution, this is going to be, for animal cells, this is very healthy for us. Yay! Now, we can compare a hypertonic solution, which is extracellular fluid, to the intracellular. So, it's 30% water on the inside. So we can technically compare the inside versus the outside and say that the inside is hypotonic where the outside is hypertonic. But water always moves to the higher concentration of solutes. Wherever there's more solutes, water goes to the party. Water moves to the party. That is what I like to say. Water moves to the party. And the way I remember this in school is if you were at a house, so here's a house, and the backyard has ice chest full of beer and the inside has chest full of beer, or whatever you're drinking, Coca-Cola, the cake, the people, you're always going to want to be wherever there's a higher concentration of people, or Coca-Cola or food or whatever. Water moves to the party. But what I mean by water moves to the party is water moves to the highest concentration of solutes. So in the case of a hypertonic solution, like if you have a lot of salt in your blood, water will move out, only move out, because it goes from an area of low concentration to a high concentration of solutes. So in a hypertonic solution, our cells are going to shrivel. They're going to shrink. Now, if we look at a hypotonic solution, we have to compare the intracellular fluid versus the extracellular fluid. If you have a 30% on the inside versus a 3% of sodium chloride on the outside, we have an osmosis or osmotic gradient. Water will want to move to the inside because there's more solutes towards the inside. Now, for these cells are going to first swell and eventually they will burst. They were lyse. Another word for burst is lyse, which means to break open. So literally it will pop open because it's overfilling with water. So that is my review of osmosis. Basically, you need to understand osmosis and what happens to cells in different levels or different types of solutions. You always have to compare the intracellular versus the extracellular to determine the movement of water. So the intracellular fluid and extracellular fluid are always solutions that are going to be composed of water, which is the solvent, and solutes, which is going to be sugar or salt or something else.